Let's see the next phosphorus halide, PCl5 or phosphorus pentachloride. Phosphorus pentachloride is prepared when phosphorus, right, white phosphorus is heated with dry chlorine in excess, which is taken in excess. What we get is PCl5. So it's 4, it's 10. It can also be obtained when phosphorus is heated with sulfuryl chloride, SO2Cl2. It forms PCl5 and SO2. So this is how it is prepared. Let's see its properties. It's a yellowish colored, pale yellowish colored solid which very easily gives white fumes when exposed to air. The reason being the PCl5 combines with the water which is present in the gaseous state or in the as a moisture in the air and forms POCl3 and HCl. These are the white fumes of HCl which we get. Now this phosphorus oxychloride then actually again combines with more of this, and ultimately at the end it gets hydrolyzed to H3PO4 and HCl. So it forms phosphoric acid. This is what is PCl5 is, first property. Then it is also a very good chlorinating agent like PCl3, and it substitutes the OH group of the alcohols and the acids to corresponding chloride. So what we find is in organic reactions, if suppose we are having CH3CH2OH, the ethanol we are having, this when reacted with PCl5 forms CH3, CH2, Cl. This is what we get along with POCl3 plus HCl. So these are the byproducts. So see again the OH is substituted by the chloride and we get chloroethane. And similarly, if we are having this acetic acid with us, this on reaction with PCl5, the OH gets substituted. What we get is acyl, or in this case we will write it acetyl chloride plus POCl3 plus HCl. One more important property of this PCl5 is it's a good oxidizing agent also, because phosphorus is present in the +5 oxidation state. So when treated with the finely divided metals like silver, it readily forms their corresponding chlorides, AgCl and PCl3 like this one. So what we get is we get these compounds. Also it is able to it can oxidize these metals. The another important thing what we find in this case of PCl5 is its structure. It is sp3 dehybridized and it's having trigonal bipyramidal structure. It's almost as like this. And we know that these three chlorines are called equatorial chlorines and this is axial chlorine. Now we know these axial chlorines are getting repulsion from the three equatorial chlorine atoms, and therefore their bond lengths are much larger. So that is why phosphorus chlorine axial bond length is bigger than phosphorus chlorine equatorial bond length. As a result, it's not very stable, and therefore when PCl5 is heated thermally, it decomposes to give us PCl3 and Cl2. Now in gaseous, in what we can write is PCl5 in gaseous or in liquid state exists in this structure, whereas in solid state it exists as ionic solid. How ionic solid? It exists as PCl4 plus unit and PCl6 minus unit. In this case, it is sp3 hybridized tetrahedral. In this case, it is sp3 hybridized octahedral. So this is how these are the properties of PCl5 we have.